Yeah, everything we learned from
Had it just perfect too, thank you. That works.
blood vessels are like the majority of the blood vessels.
I was just sat there staring at the water.
Just to update you and keep you up. Today we're gonna finish digestion. On Tuesday, you have your test, it's gonna be on the respiratory system and digestion. Those of you who missed the last test, you have to make it up on this one. On the 4th of April, there's no class, I won't be here. We had a seminar. And that's been updated. Does anybody need this respiratory system notes and study guide? We need the digestive system notes also. Digestion. You need the respiratory.
Radio shape.
I think my plan B is to be an art teacher.
I'm sorry, what's
So I don't get into nursing school at age, but I don't actually. That's not easy. It's so big. I had a hard time just navigating.
I believe this is where we left off. We were talking about the small intestine and different specialized cells.
Hopefully it-
In the duodenum, you have this thing called the common bile duct. It comes from the joining of this thing called the cystic duct from the gallbladder and the hepatic duct from the liver. And both of them carry bile from the liver and gallbladder to the duodenum. The pancreatic duct comes from the pancreas. It too empties into the duodenum and carries pancreatic juice. The common bile duct and the pancreatic duct join at this thing called the hepatopancreatic ampulla. Show you this in just a moment. And the hepatopancreatic ampulla is a tube that's formed by the joining of the common bile duct and the pancreatic. Around this area, you have this thing called the hepatopancreatic sphincter. Hepat means liver, and pancreatic means pancreas. These enter the duodenum in a thing called the major duodenal papilla. It's a hole where the hepatopancreatic ampulla enters the small intestine. So when you look at these structures, Here we have the liver. And here we have, excuse me, the gallbladder. From the gallbladder, you have the cystic duct, comes from the gallbladder. From the liver, you have the hepatic duct. They join together to make the common bile duct. Common bile duct. This organ is the pancreas, and this is the pancreatic duct. This is the duodenum. Where the common bile duct and the pancreatic duct come together, that's where you have your hepatopancreatic ampulla. They join together, and the sphincter that controls the flow of the bile and the pancreatic juice. The hole here in the duodenum is called the major duodenal papilla. Anybody need more time? The liver is an accessory organ. It's the largest gland in our body. Largest gland in our body. Has 4 lobes. Let's say called the falciform ligament that separates the left and right side, and this falciform ligament suspends the liver from our diaphragm. And our liver is located on the right-hand side. Our rib cage, just below. It should never be palpable. You should never be able to touch the liver. It should be non-tender, meaning it shouldn't cause pain. If you can feel the liver, if it's tender, that person usually has cirrhosis or alcoholic liver disease or hepatitis. It should never be palpable or tender. In the liver, you have this thing called the common hepatic duct. It leaves the liver. It's a bile duct. Bile is made in the liver, and bile leaves the liver through the hepatic duct. The cystic duct connects to the gallbladder. The common bile duct is formed by the union of the hepatic duct and the cystic duct. This is a falciform ligament, divides into right and left half. The liver is one of the few organs in our body that can regenerate itself. If you lose part of your liver, it will grow back. This is the hepatic duct. This is the cystic duct. We're going to learn the gallbladder stores bile. Bile is made in the liver. It forms a common bile duct. And delivers bile to the blood. In the liver, the basic functional unit of the liver are things called liver lobules. Liver lobules. It's a functional unit of the liver. The function, or the liver lobules, filter and process nutrient-rich blood The liver lobule is made of hepatocytes, liver cells. So as we eat food, it's largely absorbed by some things in our stomach, very few things in our stomach. Most things are absorbed into our small intestine. It goes to the hepatic portal vein. From the hepatic portal vein, it goes to the liver first. From the hepatic portal vein, it brings the venous blood to the liver lobules, to the hepatocytes, and the hepatocytes will process the nutrient, the blood with all the nutrients in it, detoxify, process it, create bile. It'll go through a thing called the central vein, go to the hepatic vein, to the inferior vena cava, and then into our circulation. So anything we eat first goes to the hepatic portal vein, to the liver, then to our circulatory system. The liver processes it. The hepatocytes have different functions. They process the nutrients in our blood. They store fat-soluble vitamins, A, D, E, and K. It performs detoxification, neutralizes heavy metals, alcohol, poisons, toxins. It produces about 900 milliliters of bile a day. That's like a quart of bile. There are specialized cells in the liver. One is called a Kupffer cells. These are hepatic macrophages. Kupffer cells are hepatic macrophages. They're white blood cells found only in the liver. Try to get through the notes today. I don't know if I'm going to have time to go over the study guide completely. Let's see. So some of the structures of the liver lobule. It's a hexagon structure. These are all hepatocytes. So the portal hepatic vein comes in, so the blood comes in through this triad, and the triad, when you take the test and you see this, you'll see, what's this blue vessel? It's the portal venule. The green vessel is the bile duct, and the red vessel is a portal arteriole. The arterioles bring nutrients and oxygen nutrients to the liver tissue itself. As food's absorbed, it comes into the portal hepatic vein. It comes to the portal venule. The blood flows through this liver lobule, and there all the bloodborne nutrients are processed. Their detoxification occurs. Their bile is formed. And all these substances make their way to a thing called the central vein. And from the central vein, it goes to the hepatic vein, to the inferior vena cava, and to our circulatory system. Yes? This packet? Bile is a yellow-green alkaline solution made from bile salts. Its function is fat emulsification and absorption. It's made from bilirubin. If you remember, when red blood cells are broken down in the spleen, one of the byproducts is bilirubin and the heme portion. It makes bile. When I talk about fat emulsification, lipids don't mix with water. Lipids don't mix with water. A lot of our intestinal juice is water. So as we eat fatty foods, as we eat omega-3 trans fatty acid, as we eat omega-6 trans fatty acids, eat olive oil, butter, animal fat, all those fats, we can't absorb it directly. It has to bind with bile. If ever you eat fatty foods, bile is released from the gallbladder, It's made in the liver, it's released, it emulsifies with the fat, it binds with it, so it can mix with water, so it can be absorbed. That's what bile does, that's what emulsification means. It binds with the fat and allows it to be absorbed with water. If ever you've eaten something really greasy, really fatty, and all of a sudden you get pain, right here, it's called McBurney's point, right where your gallbladder is. If that's real sore after you eat, you might have gallbladder disease or gallstones. If you typically after you eat something like a Philly cheesesteak or pizza, you just go, oh, that hurts. The gallbladder refers pain to your right shoulder. So some people have right shoulder that eat some fatty food and they go, oh, my shoulder's killing me. They'll think they're having a heart attack, but that's the left side. It might be the gallbladder that's affected. Yes?
Is that with fats from plants too?
There are some fats from plants like omega-3 trans fat, for instance, from avocado or flaxseed. There are some oils, like coconut oil, that comes from different plants. The funny thing is, sometimes the fats found in foods don't come from food stuff. For instance, if you get cottonseed oil, it's put in your food, but cotton isn't a food. And the pesticides and herbicides they put on cotton can sometimes mix with the fat or the oils in these plants, but they use it as food stuff, so it's not necessarily food, but you can get oils like palm tree oil is another one. The purpose of the gallbladder is to store and concentrate bile. And a couple accessory organs, you have the gallbladder, found right underneath your liver, and you have the pancreas. The pancreas is mostly retroperitoneal, meaning it's behind the peritoneum, it's not connected to it. It's found behind the greater curvature of the stomach. Its head is encircled by the duodenum. So this is the tail of the pancreas, this is the head, this is the duodenum. The tail rubs right up against the spleen. And it has two functions. It has an endocrine function that you know about by now. It helps regulate glucose levels. When our glucose level is high, the islet cells, the beta cells of the islets of Langerhans will secrete insulin, and our blood glucose level will go down. When our blood glucose level is down, the alpha cells of the islets of Langerhans will secrete glucagon and cause glycogen to be converted over to glucose, and our blood glucose level goes up. It's the endocrine function within the body. The exocrine function is for digestion. Exocrine function is for digestion. And we have different cells that secrete substances. Exocrine function. Acidy cells secrete pancreatic juice. Pancreatic juice. Enzymogen granules, they're found on the cells that secrete substances. They contain and release digestive enzymes. The major function of the pancreas is to release enzymes for digestion. Pancreatic juice is an alkaline solution. pH is above 8, more alkaline, basic. It neutralizes chyme. Remember, chyme comes from the stomach. It has a lot of hydrochloric acid in it. Helps neutralize it, along with intestinal fluid too. It has bicarbonate in it, again, to neutralize hydrochloric acid. And it has digestive enzymes. The enzymes, anything with ASE at the end. Amylase helps digest carbohydrates. Lipases, lipids. Nucleases, nucleotides. protease, for proteins. When we eat these foods, well, let me go on a little bit here. Our pancreas and bile secretion is controlled by intestinal cells found in the duodenum. These intestinal cells secrete cholecystokinin and secretin. These intestinal cells are found on the duodenum. So what happens is when we eat something, it goes into our stomach. It goes to our stomach. We chew our food, it goes to our stomach. It's exposed to hydrochloric acid. Hydrochloric acid starts breaking it down. It's exposed to pepsinogen and pepsin that starts breaking down the protein. And the chyme starts leaving through the pyloric sphincter, it goes into the duodenum. When this food stuff, when this chyme goes into the duodenum, the cells have chemoreceptors that sense that there's fat, there's protein, there's carbohydrates. And these cells, these intestinal cells, will sit there and say, no, we gotta start digesting this stuff. We gotta start chemically breaking it down. And so these intestinal cells will release as cholecystokinin. And the cholecystokinin causes the gallbladder to contract, releasing the bile so we can digest fats. Cholecystokinin will cause the pancreas to release pancreatic juice and enzymes to break down carbohydrates, proteins, fats. Cholecystokinin will cause the hepatopancreatic ampulla and sphincter to relax so that the bile from the gallbladder and liver can come through, so that the pancreatic juice can come through. It all goes into the duodenum where the chyme is being released, and all these chemicals and enzymes start breaking down the food that we just ate. And it comes in 3 millimeter spurts. And so all the chemicals made from the liver, the gallbladder, the pancreas, all dumped into the duodenum to help chemically break down the food and neutralize the hydrochloric acid coming from the stomach. That's what the intestinal cells do. They release cholecystokinin that causes the gallbladder to relax or contract, causes the hepatopancreatic sphincter to relax, and causes the pancreas to release pancreatic juice and enzymes. Digestion in the small intestine comes from the stomach. Partially digested carbohydrates, some salivary amylase, and proteins from pepsinogen and pepsin, and undigested fats. Fats don't get digested in the stomach. This is why, if I eat chicken wings, I'm going to probably watch the Sabres game tonight. I might go out with a friend. If I sit there and have some chicken wings, I'm going to regret it, because they just sit like a rock in my stomach. If I eat Burger King, Whoppers, McDonald's, whatever, I don't eat that stuff very often, and I can't digest it. It just sits in my stomach like a rock. It's all the fat. It goes in my stomach, I can't digest it very quickly or very well. But the food goes into our small intestine, from our stomach through the pyloric sphincter to duodenum. There all the chemicals are dumped into the duodenum. All the chemicals that help break down food. And it moves along through peristalsis and all those circular folds with the villi that increase the surface area. So all this food starts mushing around, all these chemicals, breaking it down, getting absorbed through the microvilli and going into our circulatory system through the hepatic portal vein, and then to the liver, then to our circulatory system, except fats. Fats don't get absorbed through blood. Fat get absorbed through, in the villi, you have a thing called MALT, mucosal associated lymphoid tissue. It goes to our lymph system. Fats bind with bile. They don't get absorbed into our blood. They go into our lymph first. They're absorbed through these lacteals, that mucus-associated lymphoid tissue, and it goes into our lymph. It goes to our thoracic duct, superior to our clavicle vein, and into our superior vena cava, and then into our circulation. All other food substances go through the hepatic portal vein. Fats go through our lymphatics. As food goes along, it's getting digested, peristalsis occurs. We got about 10 feet of small intestine. So when it moves along, it just travels along, and all this stuff is being absorbed, except gum. Doesn't gum stick in your small intestine for like 30 years or something? You ever hear that? That's a false thing. It doesn't get stuck in your stomach. But a lot of times if little kids eat something, they'll ask the parents, take a look at when they do number 2 to see if it ever comes out. You know, it's got to come out. It will eventually. And at the end of our small intestine, we have a thing called the ileocecal valve. It's a valve at the end of the small intestine. It's found between the small intestine and the large intestine. When we eat, things move along the small intestine and it goes into the ileocecal valve. And the valve is just like the pyloric sphincter. Slowly, things are dumped into the cecum of the first part of the small intestine. And the small intestine is emptied into the large intestine, all the contents. The large intestine has some unique features. One is a band of longitudinal muscles, smooth muscles, and the muscularis, in the smooth muscle portion of the large intestine, is called the tenicola. These longitudinal muscles are called the tenicola. The large intestine has a thing called haustra. These are pocket-like sacs caused by the tone of the tenicola. Haustra. Bless you.
Thank you.
We have epiploic appendages. These are fat-filled pouches found in the visceral peritoneum on the large intestine. We have different regions of the colon, and the first part of the colon is called the cecum. The last part of the small intestine is called the ileum. The first part of the large intestine is called the cecum, hence ileocecal valve, the valve between the small intestine and the large intestine. The colon is a long tubular structure that travels up, across, and down the abdominal cavity. Off the cecum, you have your appendix, located right here in the right lower quadrant. Cecum travels up, across, and down into our rectum and anal sphincter. The rectum is the part where we store fecal material. And the anal canal is the last section of the large intestine, and this is where defecation occurs. And there is one final sphincter called the anal sphincter at the end of our digestive system. So if you look, you have your gastroesophageal sphincter between the esophagus and the stomach, and then you have your pyloric sphincter between the stomach and the duodenum or small intestine, and then you have your ileocecal valve between the small intestine and large intestine, and then you have your anal sphincter. Off the cecum, you have your appendix. Cecum is the first portion. This is the ileocecal valve. These outpocketings are called haustra. This is the ascending colon. I told you your liver is located on the right side. Where the colon goes across, it's called the hepatic flexure. It's found right beneath our liver. And you have your transverse colon that goes across your abdominal cavity, just below the diaphragm. Your spleen is on the left side, and from the transverse colon where it goes underneath the spleen, you call it the splenic flexure. You have the descending colon, these are the sigmoid colon, the rectum, and the anal canal. much of the study guide I'm gonna be able to go with today. Take notes. There are 150 questions on the respiratory system and digestive system on the next test. And you can see where they're all coming from. Think of all the structure from the lungs, the liver, the pancreas. Anybody need more time? With the colon, the ascending colon and descending colon are retroperitoneal, they're hiding behind the peritoneum. And the transverse colon and sigmoid colon are anchored through the mesenteries. You don't need your large intestine to live. Some people with colon cancer, they remove the colon and they'll have a stoma or an opening, and they'll have a bag where fecal material builds up if you have your colon removed. Sometimes they'll have it directly go from the small intestine directly to your stomach lining. Those people wear a bag. I like my colon though.
I got a question.
What's that?
So when people get a colostomy, is it really, they say like it's cleaner than a butthole? Is that true?
In a matter of speaking, it is, because as the colon goes along, the chyme from the small intestine goes into the colon and the cecum first. And one of the functions we're going to talk about in a minute is the colon is to reabsorb water, reabsorb different nutrients. E. coli forms vitamin K for clotting of blood. And as the chyme moves along, it's not fecal material, but as it moves along our colon, we start making it, drawing things away, and it becomes fecal material. So this part is actually cleaner than this part, just before it goes into the rectum, so to speak. And so that's where that kind of comes from. It's more like chyme rather than fecal material. The rectum and the anus. The rectum has 3 rectal valves to stop feces from being passed with gas. And we all do this. And it's methane gas that we usually release, made by E. coli. If you eat proteins, for instance, if you have beans, E. coli turns over. One of the byproducts of E. coli is methane gas. That's where you get that crazy uncle asking you to pull his finger and you release it. The anal canal is the last segment of the large intestine. It has the rectum and the anal canal have mechanoreceptors. So as fecal material builds up in the rectum and the anal canal, you get the sensation, I gotta go to the bathroom, I gotta do number 2. And it tells you to do that. And then when we're little and we become potty trained, we have sphincters. We have involuntary sphincter around our rectum and anus. It's made of smooth muscle. And we have a voluntary sphincter made of skeletal muscle. This is the one that we learn to control when we're little kids, become potty trained. It's the external sphincter, the anal sphincter, that we control to defecate. There's a lot of veins around the anal sphincter, and if these veins get engorged, you can get 2 types of hemorrhoids. You can get external hemorrhoids on the outside of the anal sphincter, and you can get internal hemorrhoids inside the anal sphincter. Regardless, sometimes it can be very, very painful if you're sitting. A lot of times when women give birth and they're pushing, all that pressure and stress, or if someone is constipated and they're straining real hard to have a bowel movement or give birth, or sometimes guys who lift a lot of weight, they'll get hemorrhoids. The veins will become engorged with blood, and they can be very painful, and they can also bleed. And they remove them, they get this fancy 3-pronged thing with a real powerful rubber band on it, and they open it up and they go around the hemorrhoid and snap, and the rubber band will close on it, killing it, and then the hemorrhoid falls off. Not too pleasant if it's an internal hemorrhoid. The large intestine, the mucosa is simple columnar epithelium, except the anal canal. It has stratified squamous epithelium for protection against all the toxins, all the fecal material. It's like our mouth, just like other openings in the body. Whenever you need protection, stratified squamous epithelium. We have bacterial flora, normal bacteria that's found in the colon that we need. Not all bacteria is bad, but we need it. One is E. coli. It ferments indigestible carbohydrates. Indigestible carbohydrates are fiber that we get in vegetables, and it keeps our colon clean. Every time I eat a carrot, every time I eat celery, you know, I think about something you can't chew or can't break down. I think it's just scraping the inside of my colon, keeping it nice and clean. This is what happened with it. I think about my mind. But E. coli is bacteria. It's called normal flora, normal bacteria, healthy, very healthy in our colon. If we were to eat hamburger or any other type of meat that's been processed in a, when it's butchered, and they accidentally cut open the colon from the beef, from the cattle, and if it gets mixed up with the meat, E. coli can get into the meat. And if we ingest E. coli, we can get very, very sick, if not die. That's why every once in a while I see these meat recalls, say, oh, there's E. coli in hamburger and it came from Kansas, you know, this one factory or whatever. I had a friend who worked in Kansas, and he was the guy, he was the guy with the sledgehammer, and as the cattle came in, he didn't have this electric thing and just zap the cow, and he would tell me in great detail how they butcher meat. I still eat it though. You never know what's in hot dogs alone. Fiber is important. It's important for the health of our colon. Methane gas is a byproduct of E. coli. E. coli also makes vitamin K, and when we talk about nutrition, vitamin K helps form clots, blood coagulation. The large intestine, the functions of the large intestine is to reabsorb vitamins, water, and electrolytes. This is why if someone has diarrhea, you go, oh, you wonder, where's all this water coming from? I haven't eaten in 3 days and it just keeps coming out and keeps coming out. One of the functions of the large intestine is to reabsorb water. And if you're sick and you have diarrhea, the water just comes out like crazy. And a person has to be careful that they don't become dehydrated and they don't lose their electrolytes. They can, you know, slip into, become very delirious or slip into a coma. Again, the colon is not essential for life, but I like my colon. Within the 10 E. coli muscles, they move along, and the fecal material is put in the haustra, and it moves along and trails along to peristalsis in our colon. Defecation is a bowel movement. It's a mass movement to force the feces into the rectum, and we get a distension of our rectum, and we get a defecation reflex. Parasympathetic signals from the vagus nerve and the sacral plexus go to the sigmoid colon, the rectum, and the anal canal, and it causes us to relax our smooth muscle anal sphincter. Our external anal sphincter is under our conscious control. Sometimes when people are very nervous, very scared, anxiety, stress, our colon is real sensitive to emotion. Some people will be scared